What if I told you that time moves differently in space than it does on Earth? It sounds like science fiction, but it's a mind-bending reality of our universe. Welcome to the fascinating world of time dilation, where gravity and speed can stretch or shrink time itself. Imagine you're an astronaut on the International Space Station. You're whizzing around Earth at a whopping 17,500 miles per hour. At this breakneck speed, time actually slows down for you compared to your friends back on Earth. But don't expect to return as a time-traveling youngster. Over the course of a year in space, you'd only gain about 0.01 seconds. That's right, you'd be a whopping 1/100th of a second younger than if you'd stayed on Earth. But let's kick it up a notch. If you were to orbit a black hole, where gravity is incredibly intense, time would slow down even more dramatically. In the movie Interstellar, the astronauts visit a planet where 1 hour equals 7 years on Earth. While that's Hollywood exaggeration, it's based on real science. Near a black hole, time could indeed slow down so much that years might pass on Earth while only minutes tick by for you. This isn't just movie magic or theoretical physics. Time dilation affects our everyday lives in surprising ways. GPS satellites, orbiting 12,500 miles above us, experience time slightly faster than we do on Earth's surface. If we didn't account for this time difference, your navigation app would be off by about 6 miles each day. The concept of time dilation was first proposed by Albert Einstein in his theory of relativity. It shattered our understanding of time as a constant, universal ticking clock. Instead, Einstein showed us that time is more like a stretchy, flexible fabric that can be warped by gravity and motion. Scientists have proven time dilation using incredibly precise atomic clocks. They've even measured the effect at human scales. In one experiment, scientists placed one clock on the ground and another just 1 foot higher. The higher clock, experiencing slightly less of Earth's gravity, ticked just a tiny bit faster. So next time you're running late, you can honestly say you're experiencing time dilation. The faster you move, the slower time passes for you compared to the world around you. Of course, the effect at human speeds is so tiny, it would take the age of the universe to gain even 1 extra second. As we push further into space, time dilation will become an increasingly important factor in our explorations. Future missions to Mars or beyond will need to account for these time differences. Who knows, maybe one day we'll use the warping of time itself as a tool for space travel, turning science fiction into reality. So the next time you gaze up at the stars, remember, you're not just looking across vast distances, but across the very fabric of time itself. In the cosmic dance of space and time, every moment is relative, and the universe is even stranger and more wonderful than we can imagine.